Okay, now let's have a look. The first thing we are going to do is what is actually given. So let's write it down. What's the data that's provided? Now in here, you got a pump diameter. That is 30 millimeter. And then you got our load cylinder. Okay, let's call this one as lowercase d, and that one is 150 millimeter. Let's call this one as uppercase D. The hand force. Hand force is, let's say, 100 Newton, that's given. Let's call this one as F. So we got the hand force. Number of cycle. So number of cycle that's given is 15 stroke. 15, operator makes 15 complete cycle in 15 seconds. 15-second interval, 15 complete cycle in 15-second interval. So number of cycles is n equals 15. So we got that one. Now, if you look at the diagram there, well, you can't see it now. So one arm was 500 and the other arm was 150. So you need to use a lever rule, which means like how much you can actually lift. So you need to, first thing you need to do is find the force F. So first one, you find the force F, F1. F1 should be equal to 100 times, in the diagram there was 550, 500, yeah, 500 plus 50, so that's 500 and 500 plus 50, which is 550, divided by 50. So that will give you an answer for the force F1. What we done there? What's 1100 Newton. So if you remember, like on the diagram which I was showing you, this is uploaded online anyway. You have where 500 comes from. It comes from here. So let me redraw this diagram. This is the A, this is the B, this is the C. This distance from here to here is 50. This distance from here to here is 500.
150.
Yeah, 150.
150.
This was 150?
Yeah.
No, that was 500.
It says 150.
No, that's a piston diameter. You look at the diagram.
The diagram that you had up on there.
Yeah.
Is this from here? It says 150. Well, I got the wrong one. Okay, probably. It's got to leave it.
Okay. So that's where we got this force we applying here was 100. So the force here was 100 Newton, and we want to find the F1 force. So that's going to be 1100 Newton. So we got that value. Okay. Now, the next thing we need to do is we need to find out how much load can be lifted. So let's answer the part A. Part A. We want to find out how much force can be, how much load can be lifted. To do that one, because it says there is no oil leak, which means the P1 should be equal to the P2. Now pressure is force over area. So I can do force 1 over the area 1 equals to the force 2 over the area 2. And I am trying to find out the force 2. Now I need to rearrange that one. When I rearrange that one, this A2 comes on the top. So force 1 multiplied by the area 2 divided by the area 1. I can do that, or I can do that. That will give me the F2. Now I'll put the value. F1 is 1100. A2 is, what's the A2? It's up to you if you want to change the unit. Yeah, because I will do pi r square. I can do that one. But if the units are same, like millimeter, they will cancel out. So now I got 150 millimeters. So 150 pi r square I'm using. So 150, so that's going to be how much? 75, half of 150. And that will be, the other one was 30. So half of 30 is going to be, yeah. So pi r square. I don't convert millimeter to meter because they will cancel out anyway. If you put that in the calculator, obviously the pi and the pi will cancel out here as well. Don't need to do that one. So if you put this in calculator, what's the answer we got for the force 2? So it's 1100 multiplied by 75 square divided by 15 square.
27,500.
27,500. So 27.5 kilonewton. So you are applying a force of 100 Newton, and that's how much load can be lifted on the other side. Yeah, so that's the first part. Now, the second part is how many cycles are required? How many cycles are required? So I'm just going to rub that one, 27.5 kilonewton force. So I will write this F2 here. (27.5 kilonewton. We'll need that one in a minute. So if I just rub this one. Sorry guys, we don't have enough space. Okay. Now the second part is we need to find out the number of cycles. Part B. Okay. To find this one out, how many cycles are required to lift the load by 500 millimeters? So you want to lift the load up on the other side, 500. So how many times you have to move the pump? It's just like a jack in a car, like how many times you have to do it so it can move up by 500 millimeters, assuming there is no oil leak. The pump piston has 20 millimeters stroke. Okay. Now to do that one, the stroke length. Okay. The length of the stroke is 20. So I'm just going to call that one L equals to 20 millimeters. So I have the stroke length, which is 20 millimeters. Again, there is no leakage, which means the volume displaced volume of the fluid displaced from one side should be same as it's displaced on the other side. Volume of fluid displaced should be same. So Q1 equal to Q2. The formula to find the volume of the fluid displaced is Q equals to N times A times L, where L is the stroke, A is the area, and N is the number of strokes. So if I'm finding the Q1, that should be the A1. And if I'm doing the Q2, that will be the A2. So we can use this formula, and then I can just put that one here. So that formula will become N times A1 times L equal, now I need to do on the other side as well. Okay. Okay, here we got the length as 500. Now, an area, I can find the area 2. The area 2, did I got the area 2? Yeah, I can find out the area 2. So that will be the area 2 multiplied by this value, that length. Okay. Now what I can do is, the question is asking me to find out how many cycles. So N is the one that's actually missing. Everything else is fine. So let's make N the subject. And let's put the values. That's 500. That's given somewhere here. I'm not converting the units because they will cancel out anyway. Now area 2. Now area 2, I got that 150 millimeter, and the other I got 30 millimeter. So it will be pi R is going to be 75, and the other one is going to be pi, and that's 15 square. Yeah, so I got this bit. Now I need to read the question again. Okay. L. Okay, the L was that length. Now, if you put that in your calculator, please.
All right, so you're going to be giving us a formula sheet for exam.
You will be given the formula sheet. Yeah. Yes.
Second in there.
Or because the other is going to move on anyway. Then this one. So if you put that in your calculator and you got an answer, so N is 625. Yeah, or cycles rather than turns. Let me put cycles. So that has to be moved 625, so it can raise to 500 millimeter. Okay. Yep. Okay, the next bit is we need to find out the output power. So I write the value for the N here. N is 625 cycles. Okay. Now let's have a look at the part C. Okay. Now the part C is asking you to find out, well, the efficiency is given. So I call efficiency eta, which is 80% or 0.8. Efficiency is there. Now I need to find the efficiency is, what's the formula for the efficiency? Efficiency is output over the input. Yeah, so this is a form, multiply by 100%, or let's keep it that formula. Now I need to find out the input. So the question is, what is the output power? So if I rearrange the equation, that will become output equals efficiency times the input. Yep. Now, if I got the input power, multiplied by the efficiency, I can get the answer. So 80%, so I can do 80%. Yeah, so that's the 80%, which is 0.8. Now I need to find out the input. The input is the force 1. Multiply by what is the lever arm you're applying the force? Yeah, the length. Multiply by how many, what's the n, the number of cycle. Yeah, so multiply by, this is the normal n. Okay, so this becomes a 0.8 multiplied by the F1. We already have the value for the F1. Okay, the L was given, I think I just rub it off. It was 20 millimeters. Now I'm using everything in standard form. So 20 millimeters. Convert that into meters. And that was 15. So the output power if you put these ones, you will have the answer. The units for the power are watts. Watts. 264. Okay, so we got the output power as 264 watts.